So we now have three variables. We're not going to have to graph these, okay? We're talking about like lines on three-dimensional axes. We don't have to worry about graphing three things in 3 dimensions. 2 dimensions is all we need to worry about. However, we do have systems with three equations, and we could try to find the solution to this system. So this would be the intersection of these 3 lines in a 3-dimensional axis, okay? Now, you have 3 variables. You need 3 equations. You must have 3 equations with 3 unknowns to find what x and y and z are. Your solutions are going to be ordered triples. You need an x and a y and a z to solve. This is an example of a system with 3 variables. Now, we're going to start calling each individual one by a letter, just to help us stay organized when we deal with these systems, because you'll find that if you do not stay organized while solving systems of 3 variables, that things are going to kind of get out of control. And I'm telling you that 3, -5, 2 is the solution. I want you to confirm it. To confirm that something is the solution, you'll just plug in the x and the y and the z into each 3, and it needs to work for all 3. It is a shared point of these 3 lines graphed in 3 dimensions. So in A, I have 3 plus -5 plus 2. Does that equal 0? Yep. In equation B, I have 2 times 3 minus -5 plus 3 times 2. I need to see, does that equal 17? Well, this is 6. This is plus a positive, so 6 plus 5 is 11. Plus 3 times 2, which is 6. Does that equal 17? Yes, it does. And for C, I have -3 times 3 plus 2 times -5 minus 2. And does that equal -21? Let's see. -9 plus -10 is -19. Minus 2 is -21. So that works. So that is the solution. Confirmed. It works for all 3 of our equations. Okay? Now I'd like you to tell me which one of these 2 possibilities is the solution to this 3-variable system. Ready, set, go. And again, you can call this A, B, and C. Okay. And go ahead and test. Which one is the solution? Is it 5, -3, -4? Or is it -1, 2, -3? Or do both of them work? Or do neither of them work? Let's find out. So the first one fails on equation B. So far, I'm through the first two equations and everything looks good. Let's just check the third one because it needs to be a shared point for all three. I get -2 plus -4 plus -3. That also checks out. So -1, 2, -3 works. Okay? Well, let's find the shared XYZ point for these systems of three linear equations. Okay, and we're going to use substitution and elimination. Now, who here, when you're solving systems like for our quiz today, prefers substitution and like went out of your way to use substitution? Raise your hand if any of you are like that. Okay. You will find that it's actually tougher using substitution, and you'll see not for this one, but for the other examples. It's actually tougher using substitution for these systems. Okay. Elimination is actually is going to be easier. I'll show you why after we get past this one. Okay, so with substitution, just like in a two-variable system, if you have one variable solved for, you're going to want to substitute it into the other equation. However, we want to substitute C both into B and A at the same time, not just into one of them. Because if I substitute it into one of them, it actually would work out in this situation. If I substitute it into this one, so C into B is how I'm going to show that I'm substituting things. I'd get 4y plus 2 times z is equal to 20. And I get 4y plus 8 is equal to 20. We could actually solve for y here. Subtract 8 on both sides and then solve for y. Well, now that I know what y is, I can substitute z into our first one and y into our first one so that I can find x. So I'm going to say y equals 3 and c I'm going to plug into a, giving me x plus 3 times 3 plus 4 times 4 equals 20, and I can solve this. And it appears that the solution is -5, 3, 4. Now, when we have solved for a two-variable system, it's pretty easy to know if our answer is correct or not. It's not that much work that is involved, but you will see with these three-variable systems, it's important to go back and kind of check. You don't have to do the entire process. If you have a calculator, it's easy to do. You can literally type in -5 plus 3 times 3 plus 4 times 4. Does that equal 20? Well, let's see. -5 plus 9 plus 16. So that's 25 minus 5. Boom, that works. 4 times 3 plus 2 times 4. So that's 12 plus 8. That works. Boom, z equals 4. So it doesn't seem that bad. Let's look at our next guy. Now, I'd like you to discuss with your neighbors what your first step would be, what you think you should do, what your plan of attack would be. Because a lot of this, I could show you what I would do, but there's multiple ways to do things. So discuss with your neighbors. What would you do here?
Those gaps, like, how do you do that?
Those gaps are just showing you that there is no y here, that there's no z here, but it's keeping things ordered, x's with x's, y's with y's, z's with z's. It does not change the equation. It's just for neatness sake. So discuss with your neighbors. What would you do? All right, what do you think, Mr. Aguilera and Mr. Berneberg? What did you guys discuss? What would be your first instinct?
Try to solve for y.
In which equation?
The first one.
So in equation A. Now, is this, and now we usually with equations, I always say, solve for y, it'll find the slope. But is that equation A easily solvable for y? Or is there another variable that might be easier to solve for in that equation or in another equation?
X or Z.
Yeah, so which variable, Mr. Berneberg, is easier to solve for in equation A? X. All right, so maybe that's our first instinct. Did anybody else have that instinct to solve that equation for X?
Yeah.
So I'm going to manipulate this to be X equals 3y plus 12.
No.
So it is negative 3y here. So to solve for x, I need to remove the negative 3y. I'm going to add the opposite. That's a very good question. And thank you for checking. Okay, now that I have x solved for, what do we usually do once we have a variable solved for? Plug it in, right? So where would I plug this in? Can I plug this into B? No, there's no x in B. So this is the way it's set up. I can only plug A into C. So let's go ahead and plug A into C. And let's see what happens. I get 6y plus 24 plus z equals 7. I'm going to go ahead and move that 24 out of the way. Just because. 24 minus 7 is 17, negative 17. Okay? All right. Gosh, I got an equation, doesn't have x's, but unlike the previous one, I didn't get a value. I didn't get z, I didn't get x, I didn't get y. All right, discuss with your neighbors. What do you think we should do now? Discuss. Mr. Ariana, what do you think? So you're gonna manipulate this equation we just created. What are you gonna do with it? Solve for z. So I'm gonna call this equation a new equation. I'm gonna call this d. Okay, and I'm gonna solve d for z. Why? Because I notice, like, if I solve this for z, then I'll have z is equal to some version of y's. And if I notice my second equation, if I substitute something in for z and it has y's in it, I'll just have y's. And I can solve an equation with just y's for y and find the solution for y. So I'm actually now going to take d and sub it in for b. Go ahead and do that. And then, once you get what y is equal to, everything else should kind of fall into place using the equations that we already have. We find what y is equal to. After we find what y is equal to, you're going to be able to find what another variable is equal to. Once you have those two variables, you'll be able to find the third variable. So let's see if you can figure it out.
for elimination,
Uh-huh.
wouldn't you have to, like, divide by -4 because you multiplied it?
No. Nope.
You don't.
No. No. You just manipulated it so that you could use it. It's still the same equation. It just looks different. If you add things together, boom, you add things together, you divide to solve, that's your answer, okay?
Okay.
And how are we going to make sure this is the correct answer, this and this?
You can plug them back in.
Okay, maybe we check that. I'm actually going to move this up here, plugging D into B. Now, very important to be neat, orderly with all of your work. Change those negative symbols or that subtraction symbol and to add the opposite so that you know you are distributing a -3, giving me positive 18y. And then 17 times 3, what is that, 41? 51, sorry. Same side combined. I'll subtract the 51 or add -51, giving me -60. Well, y is just -3. Anybody else get y is -3? Okay, good. All right, so I have y. Can you see how you can get the x and the z? Can you get both of them plugging in y? Yes. I already have an x equals. I already have a z equals using y's. So why don't we just go ahead and things fall into place. And I get my x is 3, my y is -3, and my z is 1. Now I feel decent because first of all, those are whole numbers, and usually when we see whole numbers, we're like, oh, I must have done this problem right. Okay, but I haven't done enough of these 3 variable systems to feel truly confident. What should I do to feel really confident about this 3, -3, 1, Mr. Pottorff? Yeah, plug it into the original system. You can do it very quickly. If you have a calculator, you can do it without doing all the work. 3 minus 3 times -3, so that's going to be 3 plus 9. 3 plus 9 is 12. Okay, good. 2 times -3, -6 minus 3 times 1. So -6 minus 3, -9. 2 times 3, 6, plus 1, 7. Fantastic. So that was great. Let's look at this one. If we do this one, should be able to do that one. Things are not spaced out correctly, so you can see that sometimes the systems will show themselves being spaced out, sometimes they will not. Do you guys have this one on the left? I wrote another one down that we will do by ourselves, but let's do the one on the top left first. You don't have to write down the one on the top right yet. Okay? Let your instincts kind of lead you to do things. Now, my instincts, hopefully it's the same as yours, is to solve equation A for z. Because it's just by itself, I'm not going to have to worry about dealing with any fractions. So I'm going to add z and then add 3 to get z is equal to 2y plus 3, or 2y plus 3 equals z. Okay? Now my next instinct is to plug what z is equal to into an equation that has a z. Well, B doesn't have z. It's just C that has a z. Okay? So I'm going to plug A into C. And I get 4x plus 6y equals negative 20. Anybody else get 4x plus 6y equals negative 20 if they subbed in? Yeah? Okay. Talk to your neighbors. What do I do now? I've manipulated A, I plugged it into C, but now I got 4x and 6y, and the other equation is negative 2x plus 3y is equal to 10. What do I do now? Discuss. Yes?
Why don't you just go back to equation A if you already have y, so you just figure out what z was. So you don't have to do that whole thing.
So why wouldn't I do what? Say that again?
When you just solve that, you just solve the z.
Yep.
So why would you put it back in equation A if it has y in the...
So watch what happens if I take what z is equal to and plug it back in here. It'll end up canceling itself out because it's like you have your original equation plugged into your original. It's like, is the equation a true equation? Yes. So watch, you get 2y minus 2y plus 3, but it's 2y minus 2y minus 3. The 2y's will go away. You end up with negative 3 equals negative 3. If you ever get that, that's just a symbol for I substituted into the wrong equation. I should have substituted into another equation. Okay? So it actually does not help us. So what should I do? Who's got an idea? Who discussed with their neighbors and feels good about what they should do?
Isn't there that thing where you can like put them into parentheses?
It's kind of like substitution. I could put like 2y plus 3 into parentheses and then I substitute it in.
You do elimination.
Very, very good observation, Mr. Smith. I have an equation with x's and y's. Here's another equation with x's and y's. Now, if one of those equations is easily solvable for one of the variables, I could solve for that variable and substitute in for the other. But I don't. So watch what I'm going to do. I'm going to look at both b and this new equation, which I'll call d. And let's just write them out. Here's b, and here's d.
It cancel both terms too.
But
That ends up canceling both terms out.
it won't end up canceling both of them. So, all of a sudden, if I just say, hey, here is 2 equations and 2 unknowns, can you solve this? You'd say, yeah, that's what we did last class. That's what we did for our quiz today. How would you solve this? You would use elimination. Now it's like, well, aren't I using substitution? Well, yeah, I use substitution for the first step, but now it's kind of like, what do I do now? Well, what is the problem giving us? A situation where it's set up to solve using elimination easily. Because if I multiply the top equation by 2, this will turn into negative 4x plus 6y, which is equal to 20. And then if I add those 2 equations together, the x's will eliminate, giving me 12y is equal to 0. That's okay. Divide both sides by 12, you get y is equal to 0. Okay, now that I have y is equal to 0, you guys find what x and z are. It's a wrong note packet. Do you need the new note packet? Mm-hmm.
Where is it? I don't have it.
I have an extra copy for you. Okay, check your XYZ triple with your neighbor's XYZ triple.
Why did I get negative 11?
I don't know. So where are we? We have y is equal to 0.
4x plus 0 is negative 11.
Is that y?
Oh.
That's z. Right? So we got to be careful. I can only plug in y is equal to 0 for equations that have y in it. So if I decided to plug this into equation A, I'd get 0 minus z is equal to negative 3. Well, that gives me that z is equal to positive 3. If I plug y equals 0 into B, I'd get negative 2x plus 0 equals 10. X is equal to negative 5. So
What order do we put them in again?
just whichever ones will help you find the variables you don't know. Is there a specific order? No, this is why this is a little bit more difficult than you know the.
I mean, like in the order pair.
Oh, XYZ. XYZ. Yep. Okay. Let's do one more by yourself. This is not in your notes. You'll have to write it in. You can do it underneath the previous one or to the top right. You'll have space to start with our elimination ones. And let's see if we can tackle this one using at least an initial substitution technique all the way away. 0 temptations. Okay, please write down this problem in the top right, and let's get after it. Can you put this away? Thank you. So this is a negative 3, so it's negative z equals negative 3. This ends up being like a different type of problem. We won't have to use elimination if we don't want to. I can see right now, I can solve 2 equations to get them in terms of x. So I'll have like z equals x's and I'll have y equals x's. And then I can plug the y equals x's and the z equals x's into the other equation that I haven't manipulated. That'll help me solve for x. Then I can find y, then I can find z. Okay, go for it. Struggle a little bit. A lot of this is just kind of thinking, figuring it out, seeing what you have, seeing what you can use. If you have an equation with just x's, solve for x.
No, that's a y.
Oh, that's a y. Okay. I got an equation down here. If I solve for y, I'll have it in terms of x. Yep. That's exactly what I would do. I think we get whole numbers, so check our arithmetic. I think we end up getting whole numbers. So I would check what we did. But I love what you did. You got the z equals, you got the y equals, and you plug that in there. Negative 2 times negative 2x minus 7, positive 4x plus 14. 3 times, is this negative 4x? Wait, hold on.
No, wait, no, it isn't.
Nope.
That was negative y.
Nope, you're good. Yeah, everything looks good actually. I think that looks good, but other people are getting different answers. Okay, now it's here. So we solve for y. What did you do?
Divided by negative 1.
Okay, so you added the 4x, and then you divide by negative 1.
Yeah.
So that should be a negative 4x minus 7. So yes, that was correct. Negative 4x. Okay, what I see is two equations that can both be solved for a variable in terms of x's.
Wait.
I'll show you. Equation A, I can turn into z equals negative 2x minus 7 or plus negative 7. Equation C, I can add the y and subtract the 7, and I get y is equal to negative 4x plus negative 7. Now I have z and y in terms of x. I can plug both A and C into B. And let's see. I'd have 3 times y minus 2 times z is equal to 17. How did I know to do that? You just kind of have to look and see, like, what do I have? What can I use? And the other one, we ended up solving using elimination because I ended up with just two equations. Neither of them were easily solvable for a variable. This guy, two variables, solve for in terms of a third variable, use that. Make sure we're distributing correctly. That'd be a positive 4x, a positive 14. Now I have an equation with just x's. I can solve for x. Same side combined. I have 8x, negative 8x, plus negative 7 is equal to 17. Add 7. I get negative 8x is equal to 24. Divide by negative 8. I get x equals negative 3. Now that I know what x is, I have two equations that can help me find y and z if I know what x is. Now we're talking about college algebra. This is the real deal here. So 12 plus negative 7 is positive 5. Positive 6 minus 7 is negative 1. So I get X, Y, Z. Okay? Now, what we just discovered through doing a couple of different substitution examples is that each problem ended up being different in the way we solved it. It was not very consistent in the way we did things. It was tricky. It involves more thought, more analysis of what you have and what you can use. Once we go into elimination, we have all three variables listed at all times, so we can do this when less than all three variables are involved. We will find that it will be a little bit easier. Okay? However, it's still involved. And with elimination, you like to add equations together. We're not going to add all three together. I mean, we could if we wanted to, but we're only going to work two at a time. Our goal is to use one equation and manipulate one equation to eliminate one variable, but it needs to be the same variable from the other two. Okay? Now, I got X and Y and Z. I will list these equations off as A and B and C. So let's start by doing that. Now, if I look at equation A, it's just positive X, positive Y, negative Z equals negative 1. This equation is going to be nice and easy to work with. This is going to be kind of my starting equation because I can choose any variable and manipulate it to work with and to cancel another one. Now, it's really up to me which variable I choose to eliminate first, okay, because I have an X and a Y and a Z. Let's just say we like working with X's and Y's. You don't have to. If you like working with, Y's and Z's, you can do that. But let's just say I want to eliminate Z. Okay? Well, I have a negative Z. If I want to eliminate Z from equation B, what do I have to do to A?
Oh, sorry.
2. So if I have 2 times A and I add it to B, okay, well, let's see what that looks like. That looks like 2x plus 2y plus negative 2z equals negative 2. And then the other equation is 2x minus y plus 2z equals 8. This is 2a plus b. Add those together. Now, do you have to show all this work in the future? No. After you kind of figured out, okay, this is what I'm doing, you can kind of do it and just show the resultant equation. That gives me 4x plus y is equal to 6. Okay? I have an equation which is x's and y's. Great. Now, how can I eliminate z from c? Well, it's already negative z and positive c and positive z. If I add a and c together just as they are, without changing anything, They are set up so that something gets eliminated. I have x plus y minus z equals -1, and negative 3x plus 2y plus z is equal to -9. If I add these two equations together, we will have -2x plus 3y is equal to -10. What we've created is just two new equations. I'll call this D and E. And we can look at D and E together. We got 4x plus y is equal to 6, and we have -2x plus 3y is equal to -10. It's a system with two equations. It's got two unknowns. It's set up so that the x's and y's are stacked on top of each other. I can manipulate one of these equations to solve for the other variable. To eliminate one of the variables, I can multiply maybe this top equation by -3 or the bottom equation by 2. If I multiply the top equation by -3, I'll have negative y's that I can add together. To give me -14x is equal to -28. Solve for x. Once I have x, I can plug back into a previous equation and find y. Doesn't matter which one you choose. And once I have x and y, I can find z using one of my original equations. Doesn't matter which one you use. I get x is 2, y is -2, z is 1. Different, but it worked. Your turn. Do this problem and then you can. Use one equation to eliminate a variable from the other two. You will create a new system with just two variables. Solve that system. Once you get 1x, then you should be able to, once you get one variable, you should be able to find the other variable and find the other variable. Go. Everybody needs to practice this. I have limited confidence that we can all do this without practice. Now I notice if I add A and C together, the Y's eliminate. I didn't just jump in and just say, let's eliminate the Z's right away. You could have, but maybe try to make things easier on yourself. Maybe say, oh, the Y's might be easier to work with. If you add A and C together right away, boom, Y's are gone. And then you just have to eliminate Y's from B, and then use that. Maybe you do that. Maybe you just go for the Z's. It doesn't matter. If my way is different than yours, we should still arrive at the same answer. Mm-hmm.
I took the top equation A and white, and I plugged it into C,
Mm-hmm.
and I'm left with 4x minus b equals 8. What do I do from there?
So I probably wouldn't have solved it for Y. Okay?
Mm-hmm.
I mean, what you could do now is solve this for Z and plug it into another one, but like this is set up to use another technique, the elimination technique. Okay? So I would kind of roll with this technique, which is try to add your equations together so that a variable is eliminated. Okay, there are more examples that will be on the video. Please watch and practice because these things take practice. All right, let's look at this one. I'm going to decide to work with x's. I got negative 2x, positive 2x. Seems like x's might be easiest, though y's can work fine. Z's I wouldn't want to work with. So here we go.
I assume you just throw up the scan from pencil.
Your name. That creates equations D and E. And let's work with D and E. Multiply this guy by -1. Create opposite y's. I get Z. From that, I'll be able to get Y. And I can use Z and Y to find X in any three of these, in any of these three. Look at this situation. Set up to use elimination, so I'm going to use elimination. Again, the first one is easy to maneuver. These, so it's really just wanting me to add A and B right from the get-go. So let's just do A plus B. And I can do it right here. I get -x equals 7. That means x is equal to -7. Okay. Let's eliminate, say, the y's from A and C. So if I multiply A by -2 and to C, let's see what I get. I get -2x plus 2y plus -2z is equal to -10, and C is x minus 2y plus 2z equals 1. Add those together, and my x's and my z, my y's and my z's eliminate, giving me -x is equal to -9. Well, from this equation, I get x is equal to 9. So this should kind of scream something out. That's like, I'm not going to get the same answers. X can't be two things at all. Turns out these three equations will just never intersect on this three-dimensional plane. So if you ever see multiple solutions and they're not the same, that's your indication that there's no solution. Let's look at this one. Looks like the z's are easy to eliminate. Let's add A and C. I can do it really quickly, just looking at it. I get 2x plus 5y equals 5. And then to eliminate z's from the second one, I'll do 4a plus b. I get 6x plus 15y is equal to 15. And again, I created a new equation, d and e. And let's look at d and e at the same time. And you'll be able to notice something, hopefully. If I multiply the top equation by -3, it'd be negative 6x plus negative 15y is equal to negative 15. Add those together, and you get big fat zeros equal to 0. That means we have a situation where some of our lines are going to end up on top of each other. There's infinitely many solutions. It is not important for you to write the equations of the lines of the infinitely many solutions. We know we'll have 2x plus 5y is equal to 5. That's going to be true. And it's not important where they lie. Just know that it is a situation that you can get. We can have stated problems. 3 numbers add up to 7. Twice the second number added to the third equals the first. The first two added together is 8. What are the 3 numbers? So we set it up. This kind of screams using substitution. So I'm going to use substitution. I'll plug it into both of them. And I get these. I can simplify both of these to get this guy on the top, this guy on the bottom. Okay? I can solve this system. Call this guy A, this guy B. I can multiply B by -2 and add it to A. So I have 2y plus 2z equals 7. -6y plus -2z is equal to -16. I'm a little concerned at this answer. I'm going to check my work. This might be it. Oh, I made a mistake. Go back. Oh. Did not substitute it incorrectly. It should be 2y plus z plus y plus z. I think I made a mistake on both of them. So x gets replaced with 2y plus z plus y plus z. And that's equal to 7. The bottom one, that's good. 2y plus z plus y. So this is 3y plus 2z is equal to 7. 3y plus z equals 8. This is easily set up. Just multiply 1 by -1, add. Get z is equal to -1. Once I got that, I can find what y is equal to. And then find x. Okay. And we'll work on the other word problems in